Recently, a colleague of mine struggled to find resources for hosting a React app in an S3 bucket with a Django Rest API on EC2, using Nginx, Gunicorn, and MySQL on an RDS. Given the popularity of Django, React, and AWS, I was surprised there weren't similar YouTube tutorials. He was able to find bits and pieces at the time, but nothing full stack. So here I am creating one, and I'm pretty excited about it. In this tutorial, we'll build this to-do list app with a React front end using Vite and a Django Rest Framework backend in a virtual environment. I'll provide thorough instructions, but if you do get stuck, I will pin a comment up top for discussing hurdles and sharing solutions. We'll transition from SQLite to MySQL, covering local setup and production deployment with AWS RDS. The tutorial includes a brief intro to AWS, installing MySQL Community Server, then installing and using MySQL Workbench for setup and management. Later in this video, we'll be creating an AWS EC2 Ubuntu Instance and deploying our Backend Django project. We will set up an Nginx as a Reverse Proxy Server, acting as the first point of contact for our client requests, which will include SSL via Certbot and Let's Encrypt. We will also be implementing a Gunicorn Socket and Service for our Python WSGI server. I'll walk you through creating an AWS S3 bucket to host our React frontend, along with creating an AWS CloudFront Distribution for handling HTTPS with Amazon Certificate Manager, caching, and content delivery from the S3 bucket. We will be creating a Route 53 hosted zone and implementing a custom domain. I will even show you how to transition your Nameservers to Route 53 from services like GoDaddy. Later in this video, I will explain much more about how the items on this diagram work together. This comprehensive full stack tutorial covers advanced topics. I recommend following my naming conventions and referencing the project GitHub linked in the video description. Let's get started. I'm in VS Code, which is free and available for Mac or Windows. For this project, I created a folder on my computer earlier called TCF_to-do. This is going to be my working directory. You can create a folder anywhere on your computer for your working directory, but I would recommend sticking to the same naming conventions as me throughout this tutorial to make it easier to follow along. Once you have that working directory created, choose File, Open Folder, then Browse to and select your folder. I'm simply going to open my folder from my Recents tab. We can see our empty working directory here, which is named TCF_to-do. Now bring up the terminal window by clicking View and select Terminal, or you can use one of these keyboard shortcuts. I'm using a Windows machine, so some command syntax may differ if you are on a Mac, but I will usually give you the syntax for both operating systems. If not, you can find the equivalent Mac syntax via a quick web search. Before we get started, you will need Python installed. A quick check to see if you already have Python installed is to type Python --version. This is applicable to both Windows and Mac users. You can see the version I have installed is 3.12.6. But if Mac users have Python version 3 installed, they will need to enter in Python 3 --version. If Python is not installed on your machine, then simply download and install it from python.org. They have both Windows and Mac versions here for install. Let's start by creating a virtual environment to install our various Python packages. Make sure you are pathed to your root working directory, which is this TCF_to-do. The command is python -m venv. This is our virtual environment we just created, and it's called venv. Now we need to activate our virtual environment. So type in venv/scripts/activate. Your virtual environment is activated when you see this venv prefix before the terminal prompt. If that command doesn't work, then be sure to look up the proper activation command based on your machine and type of terminal you are using, since syntax can sometimes vary. Now we need to install all the necessary dependencies, but first we will need to create a list of those dependencies. So in your root project directory, create a file named requirements.txt. Next, I'm going to head over to my GitHub repo and copy the listed dependencies. You can do the same via the GitHub link I placed in the video description for you, or if you prefer, you can just enter them in manually. We're adding Django and Django Rest Framework, which is an extension of Django for building REST APIs. The CORS headers is just to eliminate any issues we may run into with CORS. The .env we'll get into later on when we add environment variables. And then the MySQL we'll get into later on when we swap over from SQLite to MySQL database. Okay, let's Control-S save this and close out. Make sure your virtual environment is still activated by verifying the venv prefix, then run pip install -r requirements.txt for both Mac and Windows. You'll see all of your new dependencies being installed. Let's make a new Django project. Pointing to our root directory, which is tcf_todo, type Django-admin start project backend for both Mac and Windows. Take a peek in here and you can see our boilerplate Django project that was just created for us. There is another backend directory that was created, but keep in mind, these files are related to our base Django project. We can then create multiple Django apps, and we would need to wire our apps into these main project files. But these files are not where most of our coding happens. Most of our coding happens in the Django apps themselves. Go ahead and move your requirements.txt file into our root backend directory. Change into our backend directory that was just created with cd backend. Now, let's create our Django app within our project. As a side note, we name Django apps plural and we name Django models singular. Now type Python manage.py start app tasks. This just created our new tasks app for us. This is where we'll do the majority of our coding when creating the backend logic for our tasks app. But first, we will still need to wire this app into our project and update some overall Django project settings. In the backend directory, open this settings.py file. Add the following references within installed apps. We're going to add tasks, rest_framework, and CORS headers. If you're not already familiar with CORS, which is cross-origin resource sharing, enabling the headers in your Django project is essential if your application needs to interact with resources like APIs, front-end applications, or static files from a different domain or origin. By default, web browsers block requests made from one domain to a different domain for security reasons. CORS headers are used to allow or deny these cross-origin requests. Add a reference to CORS headers middleware within the middleware section. CORS middleware should generally be placed at the top of your middleware list. This is important for ensuring that CORS headers are applied before other middleware processes, especially those that handle security, authentication, or response processing. Now we need to specify which origins we want to allow, and we want to run our front end on localhost 3000. So add the following reference. This is a whitelist of all the CORS origins that we wish to allow. Then save and go ahead and close that file. Open models.py. First, we need to define our model. A model is part of the underlying Django framework and represents the structure of your database. Models are defined using Python classes that map directly to database tables, allowing developers to interact with their data in an object-oriented way. Throughout this course, I will comment my code. That way, if you grab any of the code from my GitHub, these comments will hopefully help you out. First, we're creating a model called task, utilizing the Python model class. Then we're adding a title field with a char field max length of 100 characters. Then we add a completed field, which is actually a Boolean accepting true or false. If the user does not provide a value, then we default to false. Then down here, we add a string method to return the title. And over here is where we actually return the title. We can save and close out of this file. In the task directory, create a file called serializers.py. Now let's define our serializer. In Django, a serializer is a component that converts complex data types, such as Django model instances or queries, into native Python data types, like dictionaries or lists, that can easily be rendered into formats such as JSON or XML. It also works the other way around, by taking parsed data, for example JSON from an HTTP request, and converting it back into complex Python objects such as model instances, which can then be saved to a database. In our case, the API that we're building needs to be able to communicate requests and responses to and from both our front-end client and our database. So we need to be able to take this task Python object and convert it into JSON data. It also needs to be able to take the JSON data and convert it back to Python for proper communication. So we're going to create a serializer to do that. First, we import the Serializers module from the Rest Framework package. Then we're importing the task model from the models file. Then we create a class called Task Serializer that links the task model to the task serializer. And then within that class, we create a class called Meta. We set the model to task, and then we set fields to all fields in the model. If we didn't want to include all fields, we could always specify each individual field that we do want to include. Now we're going to define our view, so open views.py. Views are classes or functions that handle incoming HTTP requests, process them, and return HTTP responses. Views define the logic of how your API endpoints respond to various actions, like get, post, put, and delete. They serve as the bridge between your model's data and serializer's data representation to expose API endpoints. From Rest Framework, first we need to import view sets. A view set is a class-based view that provides actions like list, create, retrieve, update, and destroy on a model. Then we're going to need to import our model, task, and then we need to import the serializer, which is task serializer. First, we need to create a new class called task view set. Then we're going to set the query set to return all tasks. Then we need to set the serializer class to the serializer we created earlier called task serializer. Then save and go ahead and close that file. Now create a file called urls.py in the tasks directory. A urls.py file in an app is where you define the URL patterns specific to that app. These patterns map URLs, or routes, to specific views, allowing the application to determine which logic to execute when a user visits a particular endpoint. First, we import path and include from Django URLs. This is for routing URLs to specific views in your app. Next, we import default router from REST framework.routers for creating a router object to register our view set. Next, we import the task view set from the views.py file in the same directory. Next, we create a router object, which we've named router, to register our view set. Then we take that router object and we register our view set with it. Then we include the router.urls in the URL patterns list to make the view set accessible via the API endpoint /tasks. Then save and go ahead and close that file. Now include a task URL pattern directive in urls.py, which is located in the backend directory. First, I'm going to remove the comments. Import the include function from Django URLs. Then add a path to our URL patterns, where we're going to include the urls.py file in the URL patterns list from the tasks app. So anytime it is prefixed with /API/ in the URL, it will be routed to tasks app. Then save and go ahead and close that file. Open the admin.py file in the tasks directory. You need to register your models in this admin.py file in order to enable administrators to view, add, edit, and delete instances of the task model through the Django admin interface. It's a convenient way to interact with your data during development and testing. Pointing to our backend directory, let's run Python manage.py make migrations. This analyzes the changes you've made to your Django model and creates migration files that describe these changes. It also created an empty SQLite database. These files are essentially a blueprint for how to alter the database schema. Now run Python manage.py migrate. This applies the migration. It executes the SQL statements described in the migration files, altering the database schema. Let's create a super user in order to access the Django admin interface. So in the terminal, run the following. Enter in Python manage.py create super user --username. And I'm going to enter in TCF for my username. You can enter in any username you'd like. I'm going to leave the email address blank, enter in my password, then enter in my password again. And your super user has been created. I'm going to go ahead and fire up Django's development web server by entering Python manage.py run server. Now let's visit this URL by holding the control key down and clicking on the link. Let's enter in /API /tasks. We can enter in a couple sample tasks here. Now put in /admin and enter in your super user credentials. Now we're going to test out the admin interface. Click on tasks. I can see my first two sample tasks that I created. I'm going to add a third task. I've successfully added a third task through my admin interface. Now I'm going to go ahead and try to delete that second task. Success! To stop our development server from running in the terminal, you can typically use the Control-C keyboard shortcut on both Windows and Mac. Now I'm going to begin creating our React frontend utilizing Vite. If you're somewhat new to working with Vite React and would like to know additional information, I encourage you to also check out my Intro to Vite React tutorial. To create our app, you will first need Node.js installed. Here's their website. There are different methods of installing Node.js as you will see on their page, but the more popular method is to download the Node.js installer and install it that way. We also will be utilizing NPM, which is automatically included with Node.js. As with VS Code, it's completely free. We need to move back one directory into our root working directory, tcf_to do. Run npm create Vite at latest. Create Vite is a tool to quickly start a project from a basic template for popular frameworks. I'm going to enter in frontend for my project name. Choose React for the framework. Next, choose JavaScript for the variant. Change into our new frontend directory using cd frontend. Enter npm I for install. This will install necessary dependencies like Vite and React. Now we need to install a few additional dependencies. So enter in npm I Axios. Axios npm is an HTTP client that simplifies making API calls. It allows you to send requests and receive responses as promises, which makes it easier to handle asynchronous requests. Now enter in npm i.env. This gives us the ability to load environment variables from a .env file. Now enter npm run dev, which will run our development server. By default, Vite uses port 5173, but we will end up switching this to utilize port 3000 instead, which is just my personal preference. If you click on the link while holding down the control key, we can open up our local host in our browser. So I'm going to bring up Chrome and we can see this landing page created by Vite. Now I'm going to stop our front-end dev server with Control C. I prefer to use port 3000 for my front-end development. So from our new front-end project directory, open vite.config.js, which contains all our front-end app configurations. Here I'm defining our front-end dev server to use port 3000 instead of 5173. Within the src directory, create a folder named Components. This is a good way to organize our components in this folder. Then create a new file for your component. One important thing to note is that components in React always start with a capital letter. And it's common to use Pascal case, where the first letter of each word is capitalized. So let's go ahead and name this component tasklist.jsx with a capital T and a capital L. I'd recommend installing the React snippets extension I just showed on screen to make things a bit easier. We can type in RAFCE to use the React snippets extension. This creates a React arrow function component. I'm going to remove this React import at the top since the full library import was only required prior to React version 17. Let's put this text between some h1 heading tags. Now let's go into the root component of our React application, which is app.jsx. First, I'm going to delete these imports, then import the task list component we just created. Delete everything else in here except for an empty function, an empty return statement, and an empty export statement. Insert empty div tags. Now we can bring in our task list component object. Then enter in npm run dev. I've brought up Chrome next to our VS Code to make it easier to view our progress. Import useState and useEffect React hooks. These hooks will be used to manage the state of the existing tasks and the new task. Import the Axios library for making HTTP requests. This will define an asynchronous function called fetchTasks using an arrow function. Declaring it as async allows the function to use the await keyword inside. We are adding a try-catch statement so that if an error occurs during the request, the catch block will handle the error. This function makes an HTTP GET request to the server to fetch the tasks. The await keyword pauses the function until the request completes and the response is received. If the request is successful, res will contain the HTTP response object. If an error occurs during the request, the catch will handle the error. Here we're adding a React hook that uses the useState function. UseEffect is a React hook that runs a function after the component mounts. Inside the UseEffect hook, the function fetchTasks is called. An empty array as the second argument means that this effect will only run once. With that being said, I would like to point out React's strict mode in development can cause certain behaviors, like triggering UseEffect hooks multiple times to help developers identify potential issues in their code. This is not a bug, but an intentional feature of React's development environment. Strict mode can easily be disabled by going into the main.jsx file and removing or commenting out the strict mode tag. But this is usually not recommended. Plus, React strict mode will automatically be disabled in production build. The map function is used to iterate over the tasks array and render each task as a list item to display the list of tasks. For each task, a list item is created, and the task title will be displayed. Bring up our Chrome inspection pane and click on Console. Right now, the tasks that are being fetched are being output to the console. We can see our task array here, so this seems to be working properly. The reason why we see multiple renders in our console log is because strict mode is enabled. Now let's change console log to set tasks in our fetch tasks function. This way we can actually see our tasks render on our page. If we refresh Chrome, now we can see our tasks listed. Now we need to initialize another state variable called new task, which will contain user input for new tasks. Let's define another asynchronous function called add task. Here we're saying if the new task is empty, the function should return early and not add a new task. This HTTP post request is sent to the server. This request includes a JSON object with a key value of title and new task object. The input field allows users to enter the title of a new task. The value attribute is set to the new task state, which is updated as the user types. The onChange event handler updates the new task state with the new value entered by the user. The add task button calls the add task function when clicked. The add task function sends an HTTP post request to the server to add the new task. The placeholder attribute provides a hint to the user about what to enter in the input field. The response from the server is used to update the list of tasks displayed in the UI. Click Save, and now we can see our new add task input element and the add task button. Now I'm going to attempt to add a new task and refresh Chrome to make sure that that task is persisting. So far, so good. Now let's add a way to mark tasks as completed. This code defines an asynchronous function toggle complete, which is used to toggle the completed status of a specific task in a list. It sends a patch request to the server to update the completed status of the task. Whenever a user clicks on a task to mark it as completed or incomplete, then this function will be called via the onClick event handler of the task element, which we're about to wire up now. When the user clicks on the span, the onClick event toggles the toggle complete function using the task object as an argument. If completed is true, then put a strike through the text. If completed is false, then remove the line through. Save our component and let's test the completed task to see if it gets a strike through. Looks like everything is working as expected, so let's go ahead and add a way to delete tasks. This function takes the ID of the task to delete as an argument. When a user clicks the delete button next to a task, this function is called via the onClick event handler of the delete button. Now let's add a delete button where the onClick event calls up the delete task function, passing the task ID as an argument. Save your component and let's test it out. Okay, everything seems to be working as expected. Now it's time to style our React app. Since this tutorial is mainly focused on logic, we aren't going to delve too deep into CSS. I'm going to create a CSS module file, which is used to style components in a Vite React project. CSS modules are a way to locally scope styles, ensuring that styles defined in one component do not unintentionally affect others. Create a file in the components directory called tasklist.module.css with a capital T and a capital L. Next, I'm going to bring up my GitHub repo and copy the CSS styling from the tasklist.module.css in the components directory. You can do the same via the GitHub link I placed in the video description for you. Now paste in the CSS. In your React component, import the CSS file as a module. Vite automatically handles CSS modules when the file name follows the .module.css convention. So open the tasklist.jsx and import our CSS module by adding the following. JSX gets transpiled into JavaScript during the build process. And we can run into errors if we use the JavaScript reserved word class. So instead, we use the word class name to access our class. In our div tag, add a class name prop, then access the styles object so we can reference our scoped CSS class named tasklist. For the add task button element, let's access the add button class from our CSS module. Then for the delete task button element, let's access the delete button class from our CSS module. Click Save, and we can see our styling updated. If you don't have much experience with CSS styling, I encourage you to tinker with the styles in the CSS module. Keep your browser open at the same time like this, so you can easily see your changes take effect as you make them. If you have been following along from the beginning of this tutorial, then you will already have the two dependencies listed at the bottom of this requirements.txt file installed. I did want to point these two dependencies out for anybody watching only this part of the tutorial, where we will be connecting to an instance of MySQL and then hosting our database with RDS, which is part of Amazon Web Services. These dependencies will be necessary for this portion of the tutorial, but if you have been following along from the beginning, then you already have these installed. Open inish.py from the Backend Django Project directory. There is also an inish.py in the tasks app directory, but we want the project-wide inish.py file. Include the following: import py MySQL. Django expects the MySQL DB library when connecting to a MySQL database. We're going to use PyMySQL as a drop-in replacement. PyMySQL is a pure Python library and easier to install and maintain. The line pymysql.install as MySQLDB tells Python to use PyMySQL wherever MySQLDB is referenced. First, we're going to be installing MySQL Community Server, which is the open source edition of MySQL Relational Database Management System. Visit dev.mysql.com/downloads. Then select MySQL Community Server. A few things to note about these versions you see. MySQL Innovation is about adopting the latest features and improvements in the database system, but can sometimes not be practical for production. And MySQL LTS, long-term support version, is often considered the best choice for production environment, where stability, reliability, and extended support are critical. With that being said, at the time of this video, version 8.4.3 is actually a brand new version. So even that version will give you a connection warning in Workbench, stating some features may not work properly. I haven't noticed anything noteworthy, and certainly for the purposes of this tutorial, we will not run into any issues. We will be using Workbench in this tutorial, but I think it's important to point out that Workbench is not the only game in town. A lot of people use MySQL Shell VS Code extension, including myself. It integrates MySQL Shell functionality directly in the editor. It allows developers to manage MySQL databases, run SQL queries, and interact with MySQL servers without leaving VS Code. Okay, let's move forward. I'm going to select version 8.4.3 LTS. I'm using Windows, so I'm going to stick with that operating system selected, and I'm going to utilize the Windows MSI installer. Run the install file. Choose Next. Accept the license terms. Choose Next. Typical installation. And install. Then click Finish. Choose Next. I'm going to stick with the default installation location. Default type in networking settings. Create a password for your MySQL root user. Enter in that password again. I'm also going to create an additional user so our application can utilize those credentials. This user will just be temporary for the purposes of this tutorial, so I'm going to call the user temp user. Then enter in your desired credentials. Select OK. Just remember to store your root user password somewhere, and also be sure to store the names and passwords of any additional users you create, because we'll be utilizing that throughout our application. Choose Next. I'm going to stick with the default settings for Windows service. I'm going to stick with granting full access to the user running the Windows service. I'm not going to create any sample databases. Now click Execute. Choose Next and click Finish. Your MySQL Community Server is now installed. Now that we have MySQL Community Server installed, I'm going to install MySQL Workbench. Workbench is a GUI tool designed for MySQL databases. It provides an integrated environment to design, develop, and manage databases. Head over to dev.mysql.com/downloads/workbench. Select your operating system. I'm going to choose Windows and then the Windows MSI installer. Run the install file. Choose Next. Choose Next again. I'm sticking with Complete. Choose Next. Then select Install. Click Finish. After any installations like this, it's always a good idea to restart your machine, so I'm going to go ahead and do that now. We need to create a new localhost connection for MySQL and Workbench, so click on the plus symbol. For the connection name, enter in task_local. Enter in whatever username you had created. I created temp user. It's up to you if you want to store the password in the vault or not. If not, it'll just prompt you, but I'm going to store mine in the vault. The password I had created for my temp user is capital TEMP, capital PASS1. Select OK and click Test Connection. This is the warning I mentioned earlier. We can just click Continue anyway. And our connection was successful, so click OK. Click OK again. We need to create an empty database instance, so click on this connection. In the query window, type in create database taskdb with a semicolon. Now click on the lightning bolt to execute that script. Refresh our schemas. We can see our empty database has been successfully created. Now we're going to connect to our local MySQL database we just created from Django. In your root Django project directory, backend, create a file named .env. A .env file in a Django project is a text file that contains environment-specific variables, such as API keys, database credentials, and other sensitive information which you don't want to expose in your source code. Normally, you do not want to include a .env file in a public GitHub repository, but since this is temporary credentials for the tutorial, I went ahead and included the .env file in the project GitHub. Again, you can access that GitHub from within the video description link. I'm going to copy these credentials from GitHub and paste them into the .env. This states that we're connecting to localhost, which is 127.0.0.1. And that's the standard port 3306. That's the temp user that I created, along with the temp user's password, and taskdb is the database that we created. So paste in these credentials and make any modifications. Now open settings.py and add the following references and database connection string. From .env, import load_.env. This loads the environment variables from a .env file into the environment, making them accessible in your application via os.getenv. Import OS is used for managing file paths and environment variables. Load_.env, this retrieves our database connection credentials. Go ahead and comment out the database connection string for SQLite. You can grab our new database connection string from GitHub, or you can type it out. Our new connection says we want to use MySQL, and the os.getenv retrieves our database credentials from our .env file. cd into our backend directory, run python manage.py migrate. Now open Workbench and refresh to see our data structure has been migrated over to a MySQL instance hosted on your local machine. Our task table made it into the database, and if we right-click and select rows limit 1000, we can see there's currently no rows because we need to add data. So go back to VS Code and run python manage.py run server. Control-click your link Add /API/tasks to the end of your URL. Add a few tasks. Read my email. Do grocery shopping. Open Workbench. Right-click and select the first 1,000 rows to see if our tasks have made it into our database. Our tasks have successfully made it over. Now I'm going to add another task, Learn Django, and this time I'm going to toggle completed. Now I'm going to run the query that was created for us when we right-clicked and said select first 1,000. Select star from taskdb.tasks_task, the star meaning all records. And this is the same as right-clicking on our table and saying select rows 1,000. I can see there's a 1 for completed next to Learn Django. So things are working as expected. We can close out of that database. In this portion of the tutorial, we will be deploying a MySQL database instance hosted with RDS, or Relational Database Service, which is part of AWS or Amazon Web Services. Some AWS services fall under the free or lower cost tier. However, it's important to note that AWS pricing can vary based on your usage and configuration. I recommend reviewing the pricing details for each service on the AWS pricing calculator. It is also helpful to turn off services when they're not needed. So first off, visit aws.amazon.com to log in or sign up for your AWS account. Users new to AWS can sometimes get a bit confused on the way they should log in. Here's a brief rundown of the different login options you may come across. First, there's the AWS root user. This account is created when you first set up an AWS account. Signing in as a root user, you will have ownership and access to all resources. Next, there are IAM users. These users are created and managed by root users. IAM users are for specific individuals or applications needing access to AWS resources. There's also a totally different type of account accessible by an AWS Builder ID. This is a new personal standalone identity to access developer tools and resources like AWS training and certification. These users are limited to these types of services though. AWS has a ton of services, but if you're new to AWS, just concentrate on one service at a time. When you log into AWS, you'll first be brought to your dashboard. This widget here shows my most recently visited services. Down here, I can click on all services. And then anytime I want to go back to my dashboard, I just click this AWS symbol in the upper left-hand corner. If you have an idea of the service you're looking for, just use the search bar. For instance, if I look up EC2, I can open it here, or I can also click on the star, which will keep a link to EC2 in my header. First, search RDS. We're going to add it to our favorites, and then select the link. Click the Create Database button. Stick with Standard Create. Select MySQL. I'm going to choose the free tier. Name your database instance task DB. I'm sticking with admin for the master username. Enter in a master password. Confirm the password. For public access, I'm going to click yes, since we're connecting from localhost. I'm going to click Create New for the VPC security group. I'm going to name it VPC-SEC-TaskDB. Now click the Create Database button. We can cancel out of that. Now we can see our TaskDB database and it says creating. We need to wait until it says backing up or created before we can grab the endpoint. This process usually just takes a few minutes. While we're waiting, we can bring up VS Code and go into our .env file. Copy our previous local configuration and rename the comment to hosted. Now we can comment out our original localhost configuration. Looks like my database status says backing up, so we can click on the database instance name now. Scroll down and click on the boxes to the left of the endpoint, and that'll put that endpoint in copy. Now we can go back into our .env and paste that endpoint in where it says DB host. Our port is still 3306. Our username, however, has changed to admin. The database name is the same, and I left my password the same. We can save and close out of that file. Let's bring up Workbench. Now we have our local database connection, but let's go ahead and make a hosted connection to our RDS instance. So click on the plus symbol to create a new MySQL connection. The connection name is going to be task_hosted. If you still have your database endpoint from AWS in copy, paste it into hostname. Otherwise, you can go back and grab it. Change the username to admin. It's up to you if you want to store your password in the vault or if you prefer Workbench to ask you for your password each time you connect. I'm going to store mine in the vault. My password was temppass1 with a capital T and a capital P. Click on Test Connection. Looks like we're successful. Select OK, then open up our new connection. Type create database taskdb semicolon. Click on the lightning bolt to execute the script. If we refresh our schemas, we can see we just created a new database called TaskDB in our hosted RDS instance on AWS. But we don't have any database tables in there yet, so let's head back over to VS Code. Bring up your terminal and move into the backend directory. Type Python manage.py migrate. Bring Workbench back up and refresh your schemas. Now, if you expand the tables group, you can see our task table down below. Right-click on that table and select rows 1000. You can see there's no rows yet. Let's go try to add some data. VS Code back up and type Python manage.py run server. Open up your development server URL with Control-click. Type in /API/tasks. I'm going to add a task called walk the dog. I'm going to add another task called feed the cat, but I'm going to mark it as completed. Now I'm going to go back over to Workbench and see if my data made it into the database. Execute our script. Both of our tasks made it into the database, and you can see feed the cat has a 1 for true since we selected completed. All right, let's go back to VS Code and add a super user. Control-C to cancel our development server. Type Python manage.py create super user -- username, and I'm going to call mine temp user. I'm going to click enter to bypass the email address, and you can enter in any super user password you'd like. Re-enter your password again. Start our development server again with Python manage.py run server. Go to our development URL. Type /admin. Enter in the super user credentials you just created. Click on tasks. I'm going to click on the walk the dog task and change it to completed. I'm going to change feed the cat to feed the black cat. I'm going to add a few more tasks. Learn MySQL, mow the lawn. Everything seems to be working fine here, so let's go back to Workbench. And if we execute that script, we can see that our CRUD operations are working great on the hosted database. Now let's try making database transactions from our React front end. Click on the split icon and VS Code will open up an additional terminal window. The terminal to the left is still running our development server for our backend. We want to run our front end development server on the right hand side. So let's change into the front end directory. Enter npm run dev. Control-click that URL. And we can see that our current tasks are persisting in our React client. I'm going to add a task, learn Python. I'm going to refresh and I can see that task is persisting. Now right-click and choose Inspect and click on Console. Only errors that happen after you open the inspection window will show up. So let's refresh Chrome and see if we get any errors. So far, so good. I'm going to add another task and see if we get any errors. Host this app on AWS EC2 and S3. Okay, no errors and our app's working great. All right, let's host this app. So far, we've created a to-do list app with a React front end and a backend API powered by the Django Rest Framework. The backend connects to a MySQL database hosted on an Amazon RDS instance within AWS. Next, we are going to host our app utilizing an array of AWS offerings. Looking at this diagram, this large green shaded area is all AWS. It encompasses everything we will be including under the umbrella of AWS hosting and the associated Amazon services. Let's discuss how our data will flow based on this diagram. Starting with the front-end architecture. The client makes HTTPS requests to the application's domain name. Then Route 53 resolves the front-end subdomain to the CloudFront Distribution's IP address. CloudFront handles HTTPS caching and content delivery from the S3 bucket. The S3 bucket stores the static assets and serves them to CloudFront when requested. Amazon Certificate Manager ensures secure HTTPS communication between the client and CloudFront. Now let's discuss the backend architecture. The client makes HTTPS requests to the application's backend subdomain. Route 53 routes backend subdomain requests to the EC2 instance via its elastic IP. Nginx, our reverse proxy server, acts as the first point of contact for client requests. Handles HTTPS termination with Let's Encrypt SSL, which is managed by Certbot. Handles load balancing, handles caching, and forwards requests to Gunicorn. Gunicorn Socket is the interface through which Nginx communicates with Gunicorn. Local communication only, no need for network overhead. Secure because access is restricted by file permissions. Gunicorn Service is a Python WSGI HTTP server that interfaces between the web server, which is Nginx, and the Django application. It communicates via a Gunicorn socket. Ensures the Django app runs and processes client requests, passes these requests to the Django app using the WSGI interface, collects responses from Django and sends them back to Nginx. Django handles application logic, processes the request, interacts with the MySQL database and RDS, and returns a response. MySQL within RDS stores and retrieves application data. The response travels back through Django Rest Framework, Gunicorn Service, Gunicorn Socket, Nginx, and finally to the client. Let's get started. We need to add a few additional dependencies listed in the requirements.txt file. These requirements are only needed for production on our EC2 instance and do not need to be installed on our local virtual environment. We simply just add them to the file for now. So first, let's copy the requirements from GitHub. This is a public GitHub repository where you can find the source code for this project. There's a link to this repository within the video description. If you go into the backend directory, you will see the requirements.txt file. Let's copy this text. Now go back into VS Code, open your requirements.txt file, and paste these requirements in there. Gunicorn, or Green Unicorn, is a Python WSGI HTTP server designed for deploying Python web applications. It serves as an interface between your web application and the web server, which in our case will be Nginx. White noise will solve MIME-type errors when hosted CSS is loaded. You can save and close out of that file. Now I need to make some changes to Django's settings.py file. Feel free to copy any of this syntax from GitHub as well. First, I need to add white noise to my installed apps. Now I need to add a reference to white noise within our middleware. Since we will be doing a production deployment, set debug to false. We are going to be implementing a custom domain. You can use any domain you choose. For this tutorial, I'll be using subdomains with a root domain of thecodefarmer.com. The front end will be accessible via a subdomain named tasklist, so the full address will be tasklist.thecodefarmer.com. Then my front end will be making calls to our Django backend API via a subdomain named task-api. So the full backend address will be task-api.thecodefarmer.com. I need to add the host domain for my Django REST API to allowed hosts, which is task-api.thecodefarmer.com. Next, I need to allow React's front-end domain to make requests to Django's REST API. So within Core's allowed origins, I'm adding https://tasklist.thecodefarmer.com. Then comment out localhost, since that was just needed during development. Now add this line of code to define the directory where static files, like the ones our Django admin panel, will be collected when the collect static command is run. You can save and close out of that file. I need to make a quick change in my React app to get my app ready for production deployment, so open tasklist.jsx. You can see I'm still making calls to localhost port 8000, but for production, I want to make calls to the URL where my Django REST API will be hosted. So I'm going to change any of my localhost references to reference https://task-api.thecodefarmer.com. You can save and close out of that file. We need to clone our Django backend to a GitHub repository. There are many ways to accomplish this, so feel free to use whatever method you prefer. Be sure to move your requirements.txt file into the root backend directory if it isn't already stored there. Then click Save. In the terminal, point to the root Django project directory backend. Run git init. This will create a .git folder in your project directory containing git metadata. Run git space add space period. This will stage changes for the next commit where we say to add files from the current folder. Run git commit -m, and I'm going to say initial comment. This will save the staging area changes into the local Git repository as a unit called commit. The -m flag allows you to add a message directly from the command line. Click on the Source Control tab. Click the Publish to GitHub icon. Type task-backend for the repository name. Then click Publish to GitHub Public Repository. When I go to GitHub, I can see my task-backend public repository has been created successfully. We are going to host our Django backend on an AWS EC2 instance. That's Amazon's Elastic Cloud Compute, which is a virtual server that you can use to run applications in the AWS cloud. It is part of AWS's Infrastructure as a Service, IaaS offering, providing scalable compute capacity. First, log into your AWS account, search for EC2 and select it. Click the Launch Instance button. I'm going to name my instance task-backserver. Choose Ubuntu for your AMI or Amazon Machine image. I'm sticking with the free tier specs, including the T2 micro instance type. We are going to use a PEM SSH key, so click Create New Key Pair. My key pair name will be task-backserver-key. Stick with RSA for your key pair type and .pem for the private key file format. Click the Create Key Pair button and notice your key is automatically downloaded to your downloads location. Keep Create Security Group toggled. Keep Allow SSH Traffic from Anywhere toggled on. Toggle on Allow HTTPS Traffic from the Internet, since we're going to be using a secure protocol. Toggle on Allow HTTP Traffic from the Internet. We will disable this privilege later on. Click the Launch Instance button. Click on your instance name. Now we need to allocate and attach an elastic IP address to the EC2 instance. This will ensure we have a static public IP address for use to route our REST API traffic to when setting up our API URL. Under Network and Security, click on Elastic IPs. Click on Allocate Elastic IP Address. Stick with Amazon's pool of IPv4 addresses. Click on Allocate. Rename the Elastic IP to task-backserver_elastic-IP. Click Save. Click on the Elastic IP and click the Associate Elastic IP Address button. The resource type we want is Instance. Select our EC2 instance from the Instance dropdown. Now select the private IP address with which to associate the Elastic IP address. Click the Associate button. Open up our new EC2 instance and we can see our Elastic IP address associated and listed under Private IPv4 Address. Now move your PEM key from the Downloads folder and place it in a thoughtful location. Proper storage of your ec2.pem key is critical for ensuring security and accessibility. Store the .pem file in a directory on your local machine that is safe and secure. Never include the .pem file in a code repository, shared folders, or hard-coded locations. Losing your .pem file means losing access to your EC2 instances unless additional authentication mechanisms are already in place. So be sure not to lose it. It's also a good idea to back up your key within secure cloud storage just in case your local drive somehow becomes corrupt. Now that we have our PEM key properly stored, we're going to SSH into our EC2 instance. Developers often get stuck trying to connect for their first time. If you encounter an error connecting, be sure to search that error online, since there are a combination of things that could go wrong. Issues can often include work environment, example, trying to access your key from a cloud directory. User permission issue, example, using the wrong username for the AMI type. File permission issue, example, the .pem key file's permissions are too open. From the EC2 instance on AWS, click Connect. Select the SSH Client tab. Below where it says Run this command if necessary to ensure your key is not publicly viewable, click the icon next to the command to put the command in copy. Now instead of PowerShell or the command terminal, we want to bring up an instance of the Git Bash terminal. Git Bash comes with built-in SSH support, so you can connect to your Ubuntu server using SSH without needing additional tools. CD into the directory on your computer containing your PEM key. Simply type cd space and paste in your directory path. One thing to note with Git Bash, you're sometimes required to hold Ctrl-Shift-V to paste instead of just Ctrl-V. I placed my key in the following directory, but your location will obviously be different. Now paste in the command you just copied and hit enter. Go back to your EC2 instance in AWS. Below where it says Example, click the icon next to the command to put the command in copy. Before we leave this page, I do want you to acknowledge the note at the bottom of the page where it says, in most cases, the guest username is correct. However, read your AMI usage instructions to check if the AMI owner has changed the default AMI username. This may help you if troubleshooting is necessary. Bring up the Git Bash terminal again. Paste in the command you just copied and hit enter. If it asks, "Are you sure you want to continue connecting?" type yes and click enter. If you were prompted to enter in yes, and you are not connected after, you sometimes need to repeat entering in the last two login commands again. I can see the IP address is listed in the terminal prompt, so I know I have successfully SSH connected into my EC2 instance. Type sudo apt-get update-y. This will update the package manager. Now run sudo apt install python 3-pip python 3-dev. This installs pip and installs the development files for Python 3. Enter Y for yes. Then run sudo apt install python 3-virtualenv. This gives us the ability to create Python virtual environments. Enter Y for yes. Next run sudo apt install Nginx-y. This installs Nginx. Now head over to the GitHub repository you created earlier named task-backend and copy the clone using the web URL link. Pointing to your root directory, type git space clone space and paste in the copied GitHub URL. Now if I run command ls, which lists the contents of a directory including files and subdirectories, I can see task-backend and its contents have been cloned from my GitHub. Next, I'm going to create my Python virtual environment. Run virtualenv space venv to create your virtual environment. If I list that, I can see my environment's been created. So now run source space venv/bin/activate. This will activate our virtual environment. Notice we now have the venv terminal line prefix to represent our active virtual environment. Now I need to configure my Python virtual environment by installing the dependencies from my requirements.txt file. First, I need to cd into my task-backend directory since that's where my requirements file is located. Next, run pip install -r requirements.txt. This will install your dependencies. Now I need to collect my static files by running python manage.py collect static. Now I'm going to create my Gunicorn socket. Enter cd to move back into our root directory. Now run sudo nano /etc/systemd/system/gunicorn.socket. This will create our Gunicorn socket, or Gunicorn as many people like to pronounce it, since it's actually green unicorn. I prefer Gunicorn. In reality, I do not need to run this command from a specific directory since I'm explicitly stating my file path within my command. But I wanted to move out of our project directory to help demonstrate that these are system level files and not project level. I included a folder called host code in my public GitHub repository, which contains text files for you to copy and paste code from for the next few steps. I really encourage you to visit the GitHub link I have provided within the description area of this video, since it is extremely important you paste in the proper syntax, since one wrong character can sometimes turn into a nightmare to trace back. From that GitHub, copy the host code syntax from gunicorn.socket.txt and paste it into this file. Press Ctrl X to escape, and then Y to save, and then enter. Now let's create our Gunicorn service file. Run sudo nano /etc/etc/systemd/system/gunicorn.service. From that GitHub, copy the host code syntax from gunicorn.service.txt and paste it into this file. Press Ctrl X to escape and then Y to save. Run the following command so systemd will be aware of any changes made to the service files. Run sudo systemctl daemon-reload. Start the Gunicorn socket with sudo systemctl start gunicorn.socket. Enable the Gunicorn socket with sudo systemctl enable gunicorn.socket. Start Gunicorn with sudo systemctl start Gunicorn. Check the status of Gunicorn with sudo systemctl status Gunicorn. This tells me that Gunicorn is installed properly, active, and running. I can press Q to escape out of this pager. Or if you accidentally hit other keys and the terminal seems stuck, try hitting Ctrl C to interrupt the process. Next, I'm going to create and configure Nginx as a reverse proxy. So let's create the Nginx configuration file with sudo nano /etc/nginx/sites-available/backend. From GitHub, copy the host code syntax from nginx.config.txt, but you'll first need to modify the server name URLs to match your desired custom domains. Then once that's done, you can paste it into this file. Press Ctrl X to escape and then Y to save. Now let's ensure Nginx is running smooth. Enter sudo systemctl status Nginx. This will check if your Nginx service is enabled and active. Now run sudo nginx-t. This will test your Nginx configuration for syntax errors. Now let's create a symbolic link by running sudo ln-etc/sites-available/sites-enabled/nginx/sites-enabled/. Now let's remove some default Nginx configurations. Run cd/etc/nginx/sites-available. Then run ls. After listing the contents of that directory, we can see the default configuration that we want to remove. Remove that configuration with sudo rm-f default. Now list the contents to make sure it's gone. Enter cd space / sites - enabled. Run ls. We can see this directory also contains a default configuration. Remove that configuration with sudo rm-f default. List the contents to double check that it's been removed, and it looks like we're good to go. I'm going to show you how to replace your Django project on your EC2 instance so you can do it on an as-needed basis whenever you update your project. Remember, don't do this now. This is just on an as-needed basis. I'll deactivate my virtual environment first so I can include the activation step later to show a real-world example. So the first step would actually be to SSH Connect into your EC2 instance. I've already done that. I'm pointed to my Ubuntu root directory. First, list the files in this directory with ls. That task-backend directory is the one containing our Django project that we're going to want to remove. So type rm task-backend-r-f. This will remove the directory containing the Django project. Run ls so we can be sure the directory was removed. Make sure you have already pushed any Django project updates to your task-backend GitHub repository. Now go to your GitHub, copy your cloning URL, and go back to VS Code. Enter in git space clone space and paste in your URL. Run ls. Okay, our directory is there. Now we need to activate our virtual environment so we can run the collect static command. Run source venv/bin/activate. cd into our task-backend directory. Run python manage.py collect static. All of our static files have been collected. Restart Gunicorn, sudo systemctl restart Gunicorn, and you're good to go. The domain I am going to use is registered with GoDaddy. By default, the domain is using GoDaddy Nameservers. I'm going to show you how to change Nameservers to AWS Route 53 via custom Nameservers in GoDaddy. This process is usually similar regardless of who your domain name is registered with. First, log into your AWS account, then go to Route 53, choose Hosted Zone, click Create Hosted Zone, enter in your root domain. My root domain is thecodefarmer.com, but your root domain will obviously be different. Keep Public Hosted Zone selected. And then click Create Hosted Zone. 2 DNS records were just created for us. The top record with type NS is a name server record. This specifies the authoritative name servers for a domain. These are the 4 name server records we will need to copy into GoDaddy. So now I'm going to bring GoDaddy side by side with AWS. Next, log into GoDaddy or wherever your domain name is registered. I'm going to choose my domain name and click on DNS. Click Name Servers, then click Change Name Servers. Select I'll use my own name servers. Now paste in the 4 name servers created for us in the Route 53 hosted zone for our domain. Click Save. Select Continue. Refresh GoDaddy and you can see our new AWS name servers are persisting. We can close out of GoDaddy. Now we're going to create DNS records in our hosted zone for our REST API domain. Bring up the EC2 instance we created earlier so we can copy the elastic IP address. Where it says public IPv4 address, click on the boxes next to the IP so it puts it in copy. Let's go back to Route 53 and bring up our hosted zone. Click Create Record. For routing policy, stick with Simple Routing. Click Next. Click Define Simple Record. Type in the subdomain in our case task-API. For record type, stick with A. For value/route traffic to, paste in our EC2 elastic IP address we just put into copy. Click Define Simple Record. Then click Create Records. We need to create one more A record for our REST API domain. So click Create Record again, stick with Simple Routing, click Next, click Define Simple Record. This time I'm going to enter www.task-API. For record type, stick with A. For value/route traffic to, paste in our EC2 elastic IP address. Click Define Simple Record, then click Create Records. I can see my two A records have been created successfully and are routing traffic to the elastic IP address for my EC2 instance. Our front-end React application is going to be hosted in an AWS S3 bucket. But first, I need to create a production-ready version of my React app. Go back to VS Code and bring up PowerShell. Change into our front-end directory. Run npm run build. This creates a dist folder containing compiled and optimized React code ready for deployment. Now we need to create our S3 bucket, so bring up AWS and search for S3 and select it. Click Create Bucket. Stick with General Purpose for bucket type. I'm going to name my bucket task-frontend-bucket-tcf. Stick with all the default settings, including block all public access, since our bucket won't be directly accessed. Click Create Bucket. Select your bucket, click Upload, click Add Files, browse for the dist that was just created for us in the front-end directory when we built our project. Only select the files in the dist directory and do not select the folder that's in there. Click Open, click Add Folder. Now select any folders in the dist directory. Click Upload, click Upload again. Click Upload one last time. My files and folder have been uploaded to the S3 bucket successfully. Since my React project's build files are stored in a private Amazon S3 bucket to prevent direct access to the content, I'm going to need to create a CloudFront distribution. AWS CloudFront serves as a content delivery network, CDN, to cache and distribute the front-end files globally for faster load times. CloudFront is configured to pull content from the private S3 bucket. An Origin Access Control, OAC, or Origin Access Identity, OAI, is used to allow CloudFront to access the private S3 bucket securely. My custom front-end domain will be utilized to serve my React project from the private S3 bucket through the CloudFront distribution. Now let's create the CloudFront distribution. Search CloudFront and select it. Click Create a CloudFront distribution. For Origin Domain, choose your bucket. For Origin Access, select Legacy Access Identities. For Origin Access Identity, click Create a new OAI. Click Create. For Bucket Policy, select Yes, update the bucket policy. Viewer Protocol Policy, choose Redirect HTTP to HTTPS. Do not enable Web Application Firewall, WAF. For price class, I'm going to select Use only North America and Europe. This can generally be a bit cheaper. Alternate domain name, CNAME, click Add Item. Then enter in a domain name you have hosted in Route 53. You can include a subdomain. I'm going to enter in tasklist.thecodefarmer.com. We need to obtain a SSL certificate for our front-end domain to make it secure. So under Custom SSL, click on Request Certificate. Keep Request a Public Certificate selected. Click Next. Then input domain name with subdomain if applicable. I'm going to enter in tasklist.thecodefarmer.com and keep DNS validation selected. Then click Request. Click the Create Records in Route 53 button. Then click Create Records. The certificate status will say Pending Validation. We need to wait 5 minutes or so till it says Issued. But since this is a tutorial, I'll just jump ahead in time. Once the certificate says Issued, you can close this page and go back to the CloudFront page you already have open to continue creating our CloudFront distribution. Next to Custom SSL Certificate, click the Refresh button, then select your certificate. For default root object, enter in /index.html. Click Create Distribution. Now in my newly created CloudFront distribution, I want to create a custom error response. So select the Error Pages tab. Click Create Custom Error Response. Select 403 Forbidden for the HTTP error code. For Customize Error Response, choose Yes. For Response Page Path, enter /index.html and choose response code 200 OK. Click Create Custom Error Response. Next, I'm going to create a DNS record for the front-end subdomain I just wired into my CloudFront distribution. Go to Route 53. Select Hosted Zones. Select your hosted zone. Click Create Record. For routing policy, choose Simple Routing. Click Next. Define Simple Record. Enter the subdomain, in my case, task list. For record type, choose A. For value /route traffic to, we want to type in CloudFront into the filter. Then select Alias to CloudFront Distribution. Now select the CloudFront distribution we defined. Click Define Simple Record. Then click Create Records. All of our hosted zone DNS records have now been created. Currently, visiting tasklist.thecodefarmer.com shows my React app served via CloudFront from an S3 bucket over HTTPS, thanks to the SSL certificate issued for this URL when setting up the CloudFront distribution. However, earlier, when I updated the URLs in tasklist.jsx that are pointing to my Django API, I included HTTPS in the address. However, without an SSL certificate for that URL, we're now seeing this error. I'm going to show you how to set up that certificate so that we can get rid of this error. But first, I'm going to show you how to replace your React files in your S3 bucket on an as-needed basis. Let's say down the road you make changes to your React project in VS Code and you want to see the changes reflected in your hosted app. I'm going to show you how to do that. We obviously don't need to do this now, but it's just one of those things that's good to know. First, save your changes in VS Code and then run npm run build like we did before. This will replace the dist folder created earlier in our front-end directory. If you recall, the dist folder contains React code ready for deployment. Next, log in here to AWS and go to S3. Select your bucket and click Empty. These files will be deleted for good, so AWS will ask you to type in permanently delete just to make sure you're well aware. Click Empty. Select your bucket name so we can go back in and upload the new files. Click Upload. Click Add Files. Browse to your updated dist folder in the front-end directory. Only select the files in the dist directory and do not select the folder that's in there. Click Open. Click Add Folder. Now select any folders in the disk directory. Click Upload. Click Upload again. Then scroll down and click Upload one last time. My updated files and folder have been uploaded to the S3 bucket successfully. Now go to CloudFront and click on our distribution. Click Invalidations. Creating an invalidation ensures your updates are visible immediately because CloudFront caches the content. Invalidation forces CloudFront to remove the cached versions of the specified files. Click Create Invalidation. Type in /**. That's a wildcard to specify all files. Click Create Invalidation. Okay, that's how we replace our React project in our S3 bucket and force CloudFront to remove any cached versions. There is another way to do this though. Utilizing a single command can handle syncing local changes with the bucket contents efficiently by utilizing the AWS CLI, or Command Line Interface. It's a bit more in depth to set up, but once you have it set up, it's a breeze to use. I will end up creating a separate tutorial for that, and when I do, I'll paste a link in this video's description for you. Our React project needs the ability to make SSL requests to our backend URL, so I'm going to implement that now. I'm going to use Certbot to obtain a free SSL certificate from Let's Encrypt for Nginx on my Ubuntu server. The certificate will be valid for 90 days, so I'll be implementing auto-renewal with a timer to automatically run this command regularly, for instance twice daily, to ensure the certificate is renewed before it expires. I'll walk you through two different methods to obtain a certificate with Certbot. First off is the HTTP1 challenge. With this method, Certbot registers certificates via HTTP on port 80. During our EC2 instance setup, I enabled Allow HTTP traffic from the internet to prevent registration failure. HTTP on port 80 is also needed for renewals, so you can either keep it permanently enabled or temporarily enable it for manual renewals before expiration. Next is the DNS1 challenge. This method requires creating a DNS record with a token, which Certbot verifies. It's ideal for domains without HTTP traffic or for obtaining wildcard certificates like *.example.com. The downside is it's slightly more complex to set up. Keep in mind the steps may vary based on your environment, Ubuntu version, and Certbot. This tutorial introduces core concepts and options so you can adapt them to your scenario. Okay, let's get started with HTTP1 challenge. Bring up VS Code and SSH Connect into your Ubuntu server. I added a file named certbot.methods.txt in the host code folder of the public GitHub repo linked in the video description. This file includes step-by-step instructions with copy-paste commands. Just be sure to update domain-specific syntax. This command installs Certbot on your server. This runs Certbot with the --Nginx plugin using -d to specify the domain names we'd like the certificate to be valid for. Enter in your email address. Type Y. Type N. Our certificate was successfully deployed. This is how you verify Certbot auto renewal. I can see that it's enabled and active, so that's good. This command simulates the renewal of our existing certificate that we just received. The renewal simulation succeeded, but that's only because we're currently allowing HTTP traffic to our EC2 instance. If you were to remove the allowance of HTTP traffic to our EC2 instance and then rerun this command, you would notice it would fail. Before we move on, I am going to open up my Nginx config file to show you that it's been modified. If I scroll down, I notice this file is now managed by Certbot and includes certificate details. Next, I'm going to show you the second method, which is DNS1. But first, we're going to need to remove our certificate, update our Nginx file, and remove Certbot. This command will list all the certificates we have available. Run this command to delete a certificate. We only have this one certificate, so enter in 1. Enter Y. Looks like I doubled up on step numbers. Let me fix that. This command will clear the Nginx config file by truncating the size to 0. This command will open our Nginx config file. There's no more syntax in there since we just truncated the file. I'd like to set this configuration file back to the way it was before Certbot modified it. So I'm going to grab my original syntax from nginx.config.txt. Copy this text and paste it into our configuration. Control X to exit, Y to save. This will uninstall Certbot. Y to continue. In the last step, log into AWS and go to our EC2 instance. Click on Instances. Choose our instance. And then click Security. Scroll down and click on our security group. Edit inbound rules. And delete the rule allowing HTTP, since we will no longer need HTTP with our next Certbot method we are going to implement. Click Save Rules. Now I'm going to implement the second Certbot method, which is DNS1 challenge. This will reinstall Certbot. This command will download and install Acme DNS Certbot, which will allow Certbot to operate in DNS validation mode. This marks the script as executable. And this will open the script so that we can then add a 3 to the end of the first line. So Python 3. Control X to exit, Y to save. This will move the script into Certbot's Let's Encrypt directory so Certbot can load it. This command is going to run Certbot and force it to issue a certificate using DNS validation. Just remember to update the syntax containing the domains. Enter in your email address again. Y. I normally click N for no. Some challenges have failed. That's because we need to create our DNS records. But running this command instructed us which records we need to create. So scroll up a bit. I need to add these two CNAME records in Route 53. The first part is going to be the record name, so copy that. Go into Route 53. Hosted zone. Select your zone. Click Create Record. Stick with simple routing. Next. Click Define Simple Record. Paste in the DNS name we copied. Since we're adding this record to the hosted zone for our root domain, by default, Route 53 is going to add .thecodefarmer.com as a suffix. So remove .thecodefarmer.com from the end of this. Otherwise, our DNS record name will be .thecodefarmer.com.thecodefarmer.com, and Certbot will fail because it will not be able to find the record. Choose CNAME. Go back to VS Code and copy the CNAME record value. Go back to Route 53 and paste that value into our simple record. Click Define Simple Record. Click Create Records. I can see my record was created. Now I need to create the second record. Click Create Record. Stick with Simple Routing. Click Next. Define Simple Record. Go back to VS Code and copy the record name for the second record. Go back to Route 53. Paste this name in. And remember to remove the root domain like we did with the first record. Choose CNAME. Go back to VS Code. Copy the second record CNAME value. Go back to Route 53 and paste that value in our simple record. Click Define Simple Record. Create Records. Now I can see both records are there. Go back to VS Code and repeat running the command from step 6, where we run Certbot requesting a certificate. If we scroll up a bit, we can see I successfully received my certificate over DNS with HTTP disallowed. The return syntax says Certbot has set up a scheduled task to automatically renew this certificate in the background. But I'm going to go ahead and show you some commands anyhow, just so you have them in your toolbox. This command will enable the Certbot timer. This command will start the Certbot timer. This will verify Certbot auto renewal by checking the status of Certbot timer, which is enabled and active. Now let's test out auto renewal. Awesome. All simulated renewals succeeded. Let's go test our app. It looks like my front-end TLS or transport layer security is working properly. Let's go check the back-end for any errors to verify our new back-end certificate is all good. I'm going to open the Chrome inspection console and refresh the app to see if we're getting any errors. Add a few sample tasks. Go fishing. Get a bite to eat. Test the completion. And test delete. This is great. Our app is securely hosted with a custom domain and working properly. I really hope you enjoyed this full stack tutorial. If you did, please like, subscribe, and hit the notification bell so you don't miss future tutorials. I'll pin a comment at the top where you can share any challenges you faced or solutions you've discovered. Let's collaborate and make this a great resource for everyone.